Hey guys, and good morning. So in this video, we are going to be doing understanding exponential growth and decay functions. So we're not quite out of exponential growth and decay yet. We're taking it a little bit deeper just to make sure that we are understanding the way that the functions are written with the word problems as well. So today we're diving into understanding them. So we have Mr. Frank. He bought a car that cost $33,000. The car depreciates approximately 12% of its value each year, which equation represents the value V of the car after T years. So I would suggest going ahead and just writing out the equation as you usually would. So we know that we have the word depreciates. Okay, web painted it. So we know that we have the word depreciates there, which lets us know that it's going to be a decrease. Or a decay. So we're using y is equal to a times 1 minus r to the t power. And then this whole what's in parentheses is your base or your b value, but that necessarily isn't needed for the word problems at the moment. But we know that it's decaying, so we need to use the subtraction sign. So our initial value was 33,000. So 33,000 goes out first. And nope, can't eliminate anything. Then we have 1 minus, my percent right here was 12%, but don't forget I need to change that to a decimal. And by doing so, I move it 2 places to the left, so 1, 2 becomes 0.12. And then it didn't give me the time, so I'm going to use T for time. Okay, now off the top of your head, it looks as if A and B could be correct because we see the rate right in there at 0.12. But don't forget that your equation has 1 minus the rate because it is depreciating. So that means that instead of it being 0.12, when I do 1 minus 0.12, I get the number 0.88. So we have 33,000 times 0.88 times t. Okay, now making sure that we have t in years is what it is our exponent. So D is the correct answer for this particular problem. Okay, next one. Amy invested $3,200 at an annual interest rate of 8%, which equation models the value of the investment V after T years. So again, T is your years. All of them have T, so you can't cancel anything out on that one. We know that my initial amount was $3,200, so that goes out first. We know it was a growth, so I'm going to do 1 plus my percent, and my percent was 8%, and I'm going to change it back or to a decimal by taking it back 2 decimal places, or technically it's dividing by 100, and then T is there. So 3,200 times 1.08 to the T power. Okay, so C is going to be your correct answer there for that one. And then as you see, the incorrect answers have the decimal point in the wrong place with the percent of being 8. So just be very, very careful with that. Okay, suppose a forest starts with a deer population of 35. The population is increasing at a rate of 12% per year. Okay, so we have 35 is the amount of deer that we start off with. It's decreasing, it's increasing, so that's messed that problem all the way up. At 12%, so 12% needs to be changed to a decimal by taking it back 2 decimal places, dividing by 100. So we have 1 plus 0.12 to the T power. So 35 was my initial value, so it's what goes out in front. A and B put the percentage out front, so that is incorrect. And 1 plus 1.2 is 1.12 to the T power. Okay, so D is your correct answer, and C was incorrect because they just went ahead and plugged in that percent. But don't forget, with something that is a growth or a decay, we need to have the 1 plus or the 1 minus to figure out what our base value is for our exponent, or the base of our exponent. Okay, Moving right along. Okay. Charles buys a new television for $3,800. Okay, that's represented right here in the initial value. What percentage does the value of the television decrease each year? So I knew it was decreasing. Well, one of the problems that it was decreasing. Second of all, I knew it was decreasing, don't forget, because this was less than 1. Okay, so at first glance, it looks like, oh, my percentage is 70%. Remember, it took 1 minus some number and got 0.70%. Okay, don't forget that. So technically, the equation would be to subtract 1 from each side. So negative x is equal to negative 0.3. And then you divide by negative 1. Okay, remember all of that wonderful thing. Well, that was a negative. So then 0.30. Okay, all of that is good and great, right? But technically, if you just take, because I know that you do 1 minus or 1 plus, 1 minus 0.70, we get the other end of that percent that we need, which would be 30%, and that is option C over here. Be very careful not to choose A because of that decimal point. Don't forget it's a decimal, changing it to a percent, multiply by 100 so you get 30%. And they threw B and, if I move this out of the way, D in there to trick you because you are already looking at it. You're like, oh, the percent is already there. Don't forget your equation for something. This one is decreasing. So it's A times 1 minus R to the T power. So this part right here in this formula has already happened, so we kind of need to work in reverse to figure out what that rate is. Okay, so be very mindful and careful of those problems. Same with this one. So the function v times t is just like you're putting in the time. It's 17,500 times 0.88 to the t power for the time there. Okay, in dollars of a car after it was purchased. Okay, so it's decreasing, and I know it's decreasing because my decimal right there is less than 1. It's 0.88. Okay, so already I know that that is not the percent. So 0.88 is not the percent because there's no 1 minus over there, and I need to do that. So we're going to take 1 minus 0.88, and we get 0.12. Okay, so I know my answer is 0.12%, but is it an increase or is it a decrease? Well, let's look back at our original. Our original up here was less than 1, so it is decreasing at that rate. It's a exponential decay. Hopefully, I know I'm going through this quick, but because I still want the video to be super, super long, but hopefully this is starting to make a little bit of sense to you guys. Okay, the population of a town is represented by the function P times T. T is being your time there. We have 7,601.04 to the T power. T represents the number of years. See, that's the time. What was the population in the year 2000? Okay, so if T represents the number of years since 2000, okay, it was, I don't know what I'm trying to say. Think about that one. Okay, so T is the numbers since 2000. But it wants to know the population in 2000. So did any years pass yet? No, so that time is 0. Okay, so if I do 7,600, 4 to the 0 power, I do 7,600. Anything to the 0 power, don't forget, is the number 1. So 7,600 is your answer. Okay, you also could have seen that from the equation because if we can recall and remember, the A value in my equation is my y-intercept. So anytime that x is 0, that is going to be your y-intercept. Sorry, y'all, I'll try not to sneeze in the video. And again, our formula is A times 1 plus R to the T power. A is your initial value, and when T is 0, technically. So I could have looked at it from the equation, but you also could do some math with T being 0 and get the exact same answer, whichever you are more comfortable with. Okay. So this is one of the last ones. I think it is the last one. It is. Okay, so Brian and Mason bought cars at the same time. The function f of t is 21,500 times 0.87 to the t power. Models the value of Brian's car after t years after purchase. G of t, which is just another function notation because it's two different people, he purchased his car at $19,200 and is depreciating. And then again, I know it's decreasing because my decimal point there is less than 1. So is depreciating at a rate of 91%. Well, not 91%. I need to figure out my percent. So what is the approximate difference between the values of the cars after 4 years? Okay, so they went ahead and already calculated the whatever rate is depreciating. It's in my particular equation already, so I'm going to take care of Brian's first. Okay, and it says after 4 years, so my time is going to become 4 years. So 21,500 times 0.87 to the 4th power. Okay, and don't forget we have decimals.com that we can use. So 21,500. I'm going to use my parentheses, so my little things will go away over there on the keyboard. I already forgot the number. 0.87. And then my exponent was 4 years. 1,500 4 years. Okay, so that's 12,317.30. 12,317.30. 12,317.30. 12,317.30. I went ahead and rounded that on up. Yep. Okay. Now the next equation that we have is going to be for Mason. Okay, so Mason's is 19,200 times 0.9. 19, I meant 91. Went dyslexic on y'all there for a second. So 19,200. Okay. 19,200 times. What was the percentage? 0.91. And then my exponent again was 4 for the time, and that value is 13,166.39. 13,166.39. 13,166.39. Okay, so now it's asking for the difference between those values on other two cars. So now we need to subtract these two values because it says the word difference. Okay, so I'm going to take 13,166.39. So I'm just going to go ahead and take those values, 13,166. We're going to round that to 39, sorry. And we're going to subtract 12,317.30. And that value is 849.09. 849.09. 849.09. And the closest value to that is going to be B, $850. And I'm going to go ahead and go with that one. I know it's not like exactly rounded correctly, but we did some rounding in our calculation over there before I did my subtraction. Okay, so again, today's takeaway is definitely looking at the rates and the percentages inside of your problems here. So it looks as if it is 88%, but don't forget it's either 1 minus or 1 plus, and that's the rate that you need to figure out. So there's some calculation to do whenever you don't see 1 minus or 1 plus in there. Okay, so good luck with this. If you guys need me, I'm just a private comment away or shoot me an email.